Hey Raiders, welcome back to Dr. Mitt's classroom. I'm making a short video that hopefully will be of assistance to you as you review for upcoming assessments with regard to the ozone layer. In particular, there are three things about the ozone layer that we want to keep in mind. First is the formation of the ozone layer. How does it form? Second is the function of the ozone layer. What does it do for us? How does it function? And third, how do we care for the ozone layer? Is there a way that we care for it or a way that we could neglect it and harm it? And so I'm doing this video to kind of walk you through a process. We'll produce a diagram here. I will label this the ozone layer diagram. And in many ways, it's quite simple. There's some complex science behind this, but it's actually a fairly simple diagram. Because it's happening above Earth, up in the atmosphere, of course, we're going to draw and label the sun. And one of the key things that we get from the sun is ultraviolet radiation. I will always abbreviate with UV. Now, again, remember that what we're talking about here is happening up in the stratosphere. This is not down in the troposphere, the weather layer where we live. This is up higher in Earth's atmosphere, in the stratosphere. So don't confuse this diagram with the greenhouse effect in the atmosphere diagram, where we have ultraviolet hitting the Earth's surface, partial absorption leading to a lengthening of wavelength, which then causes the energy that bounces off of Earth or things on the Earth to be in the form of infrared. This is not that diagram. This is a separate diagram. This is happening up in the stratosphere. When ultraviolet comes from the sun and interacts, I'm going to draw it as if it's a mathematical equation. It's not. But when it interacts with O2, the normal oxygen molecules that we breathe in the atmosphere, and remember, this is part of the homosphere, these gas layers where the lowest part of the atmosphere, the homosphere, is where there's well mixed. There's a sameness about it. And so there's nitrogen, 78%, oxygen, 21%, and then 1% of other gases, things like argon. So when ultraviolet comes from the sun and interacts with O2 in Earth's atmosphere, that leads to the production of O3, which is ozone. O3 is what we call ozone. And this is what we can call an interconversion process. Interconversion happens so that when ultraviolet interacts with O2 in the atmosphere, it produces O3. And then that layer of ozone up in the stratosphere is known as the ozone layer. Now, the amazing thing about this is that the ozone that's produced here is produced again by ultraviolet interacting with O2 to produce O3, and then the O3 actually absorbs or blocks the ultraviolet. Pretty amazing idea. Ultraviolet interacts with O2 to produce O3, which then blocks most of the ultraviolet that comes into the atmosphere. So we'll label that as such. The ozone layer absorbs 97 to 99% of sun's ultraviolet. That is a good thing. So the ozone layer forms, the formation of the ozone layer happens through this interconversion process. UV comes into contact with O2 to produce O3, which then blocks or absorbs most of the ultraviolet that comes from the sun. So that's the formation of the ozone layer. Here, we're talking about the function of the ozone layer, the function. And in fact, that function is that it serves as Earth's sunscreen. It's not Earth sunscreen as much as it's a sunscreen for us as inhabitants of Earth. But it is Earth sunscreen. It serves the same function. It is blocking ultraviolet radiation. I should have drawn the surface of the Earth down here, and I'll put some plants. And I'll add an anonymous 6th grade student, as is my want. And right now there's a smile on that 6th grade student's face. However, there's a problem. The problem comes to the whole issue of the care of the ozone layer. Humans have not always done a great job of caring for the ozone layer. In fact, what we understand is that because humans used ozone depleting substances, that an ozone hole, I'm putting this in quotation marks because it's really a thinning, an ozone hole formed because humans used CFCs and BFCs. These are also known more generally as ozone depleting substances. CFCs are chlorofluorocarbons, BFCs are bromofluorocarbons. So these are elements that are halogens, they're gases that were parts of substances that humans used in particular types of industrial applications. Lots of the old aerosol cans, hairspray, spray paint, think of something like WD-40. Many of these cans back in the day used these substances as what are called accelerants, or they were also used in refrigeration systems, like in old refrigerators. In any case, these halogens, these gases, the chlorine, fluorine, were moving up into the stratosphere and were causing thinning of the ozone layer. And this was first reported back in the late 60s, early 70s, and caused some concern, at least to those who understood the science. If there's thinning in the ozone layer, what that can mean is that too much ultraviolet can come down here, which would wipe the smile off of the 6th grader's face, because that would mean possibly sunburn, possibly skin cancer, possibly not even life could continue if too much ultraviolet were reaching Earth's surface. Again, I want to remind you, we've drawn this student down on Earth's surface. This is happening up in the stratosphere, but it affects us down here in the troposphere on Earth's surface. So we have the formation of the ozone layer through this process. We have the function of the ozone layer as Earth's sunscreen in a sense. But then we have this issue where we weren't caring, as humans, we weren't caring well for this layer, this important sunscreen layer for us. So this was a human-caused problem. Happily, when humans cause problems, we can sometimes also fix those problems. We sometimes can't. But this is a problem that we caused, and that as we came to understand what we had caused to happen, a thinning of the ozone layer, that we could respond. And the response was to ban the use of these chlorofluorocarbons and bromofluorocarbons to try to decrease the use of ozone depleting substances. Well, there are two key principles, of course, that come out of this study. First of all, there's incredible fine-tuning. So we've got two key principles. The first is what has been referred to as the anthropic principle. And in our context, in earth science class, when we think of the anthropic principle, we're thinking of this. The universe is finely tuned for human existence. I don't mean to imply that all of the universe is hospitable. What I mean is that things are happening in the universe, in our solar system, in our galaxy, etc., on Earth that are appropriate for life. Some people have referred to our planet as a privileged planet. We've got some incredible fine-tuning, some great systems that are working in particular ways that make life, as we know it, possible on the planet and actually fruitful and abundant on this planet. So we know this through what? Through doing science. When we do science well, we discover this fine-tuning. We come to understand this fine-tuning. Then we have before us a decision, an important decision. It's a metaphysical decision about what we're going to do once we understand the fine-tuning. And I refer to this in terms of environmental stewardship. Environmental stewardship. So what do we mean by that? First, we're talking about the environment, Earth's systems, but we're talking about stewardship. Stewardship means to manage or care for something. Often it's something that doesn't even belong to us. A steward can be someone who manages someone else's affairs. And so we have an environmental stewardship. We have a planet with fine-tuning, certain systems that are critical for human and other organismal existence. And yet what we understand is that this fine-tuning, which is understood through science, that in environmental stewardship, we make a metaphysical decision based on scientific understanding to protect Earth's systems. The same sort of thing comes into play in the greenhouse effect in the atmosphere and carbon cycle diagram, where we've got a certain amount of fine-tuning. It's a good thing that ultraviolet comes into Earth's atmosphere, that it warms the Earth as infrared radiation is in the atmosphere. That's a good thing. It keeps our planet within a particular livable temperature range. But if we have too many greenhouse gases, that traps the infrared, which can lead to atmospheric warming that can have dire consequences, horrible consequences for our planet. And so there are concerns about the use of fossil fuels. As we learn from studying the carbon cycle, we understand there are some other factors, other carbon parts of the carbon cycle, carbon sources and carbon sinks that also play into our whole understanding of that cycle. But here, what we understand is first that there's fine-tuning. We understand that through doing science well. Second, we have a metaphysical decision based upon scientific understanding to protect Earth's systems. Again, it could be with regard to greenhouse gases in the atmosphere. It could be with caring for the ozone layer because of this important function as Earth's sunscreen, what it does for us. This is consistent with what we do at Randolph School, right? We're concerned about nurturing all. This is not just a selfish thing for me individually or for even my family, but for future generations. It's for everyone to care for the fine-tuning that exists in Earth systems. Thanks for your attention. If you have questions, make sure that you let me know soon.